everyone, and welcome back to the channel. In today's video, I'll demonstrate how to use this motor rating calculation Excel sheet to determine the correct motor size for a centrifugal pump. This calculation sheet automatically calculates the hydraulic power, brake power, minimum motor rating, and recommends the appropriate standard motor size based on the input operating conditions. Let's get started. First, let's look at the input data section. The first input is the pump flow rate. For this example, I'll enter 100 cubic meters per hour. Next, I'll enter the pump head. The head for this example is 50 meters. Now I'll enter the liquid density. Since we are using water, I'll enter 1000 kilograms per cubic meter. Next is the pump efficiency. I'll enter 75%. The last input is brake power, also called shaft power. This field is optional. If the brake power is already available from the pump vendor or from an existing pump data sheet, you can enter it directly here. Otherwise, simply leave this field blank, and the calculation sheet will determine the brake power automatically using the process data entered above. Now that all the required input data has been entered, let's move to the output section. Notice that all the results have been calculated automatically. Let's review each output one by one. The first output is hydraulic power. For this example, the hydraulic power is 13.625 kilowatts. Hydraulic power is the useful power transferred by the pump to the liquid. It represents the energy required to move the fluid through the piping system. The next output is brake power, also known as shaft power. For this example, the calculated brake power is 18.17 kilowatts. This is the mechanical power that must be delivered by the electric motor to the pump shaft. Since every pump has hydraulic and mechanical losses, the brake power is always greater than the hydraulic power. The next output is the minimum motor rating. For this example, the minimum motor rating is calculated as 20.89 kilowatts. This value includes the recommended engineering design margin. It represents the minimum motor capacity required to drive the pump safely and reliably under normal operating conditions. However, electric motors are manufactured only in standard power ratings. Since 20.89 kilowatts is not a standard motor rating, we cannot select a motor with exactly this capacity. Instead, we always choose the next higher standard motor rating. The calculation sheet performs this selection automatically. For a 50 Hz application, the recommended motor rating is 22 kilowatts, based on the IEC standard motor rating. The equivalent NEMA standard motor rating is 30 horsepower. Similarly, for a 60 Hz application, the recommended motor rating is also 22 kilowatts, based on the IEC standard, which is equivalent to 30 horsepower based on the NEMA standard. Displaying both kilowatts and horsepower makes this calculation sheet useful for projects around the world. Engineers working with IEC standards can refer to the kilowatt rating, while engineers working with NEMA standards can use the equivalent horsepower rating. So, for this example, the pump requires 13.625 kilowatts of hydraulic power, 18.17 kilowatts of brake power, a minimum motor rating of 20.89 kilowatts, and the final recommended standard motor size is 22 kilowatts or 30 horsepower. Now let's look at the API recommended motor sizing table on the right side of the worksheet. This table applies the appropriate design margin based on the calculated pump power. For lower pump power ratings, a higher design margin is recommended. As the pump power increases, the required design margin decreases. The calculation sheet automatically checks the calculated brake power, applies the appropriate design margin, calculates the minimum motor rating, and finally recommends the next higher standard motor size. This eliminates manual calculations and helps engineers select motors according to standard engineering practice. Now let's understand the power flow diagram shown below. The electric motor converts electrical energy into mechanical energy. This mechanical energy is transmitted to the pump shaft. This is known as brake power or shaft power. Inside the pump, part of this energy is lost because of hydraulic and mechanical losses. The remaining useful energy is transferred to the liquid. This is called hydraulic power. A simple way to remember this relationship is: motor power is greater than brake power. Brake power is greater than hydraulic power. Finally, let me show you another useful feature of this calculation sheet. If you already know the brake power from the pump vendor or equipment datasheet, you don't need to enter the flow rate, head, density, or pump efficiency. Simply enter the brake power directly into the brake power input cell. The calculation sheet will immediately determine the minimum motor rating and recommend the correct standard motor size. This feature is particularly useful during equipment selection, vendor document review, and detailed engineering activities. I hope this tutorial helps you understand how to use this motor rating calculation Excel sheet for selecting the correct motor size. If you found this video useful, please support the channel by clicking the like button, subscribing, and sharing this video with your colleagues and fellow engineers. You can download this Excel calculation sheet using the link provided in the video description. Thank you very much for watching, and I'll see you in the next video.